Okay, let's just jump right in. Imagine you've got this massive high-definition video signal, a live sports event maybe,
Sure.
and you need to send it, say, 75 miles down a single wire without it turning into just static.
Right, which you can't do, not with a standard copper cable anyway. It's just physically impossible.
Exactly. So today, we're doing a deep dive into the little box that makes that happen every single day, the Thor Broadcast F-1ASI unit.
Yeah, and our mission here is to really get into the engineering of this thing. The F-1ASI, it's a very specialized media adapter. It's built for these crucial video signals, DVB ASI and SD-SDI.
And why is it so crucial?
Well, the sources show us that copper can only carry these huge video files, maybe a few hundred feet. After that, you start getting attenuation, noise, interference. It just falls apart.
So this unit is the workaround. It's the shortcut.
It's the required shortcut, yeah.
Oh.
Keeps the signal pure over, well, vast distances.
And that's really the core question, isn't it? How does a professional video stream that starts on a normal coax cable suddenly get the power to travel up to 120 kilometers?
It does it by swapping electrons for photons. That's the simplest way to put it.
Okay.
The F-1ASI is a general-purpose copper-to-fiber serial converter. So it takes that heavy, noisy electrical signal and converts it into a pure optical carrier signal, a light pulse.
So think of the copper signal like water in a garden hose. It loses pressure pretty quick.
That's a great analogy. And the optical signal is like a laser beam. It holds its focus and its integrity over these incredible distances.
So this isn't just about distance. It's about signal purity.
Yeah.
Getting rid of all that noise.
Precisely.
And for anyone listening who isn't in a broadcast studio all day, these signals, DVB ASI and SD-SDI, what are they really?
They're basically the two workhorses of professional video. SD-SDI, that's your standard for uncompressed digital video inside a studio.
Okay.
And DVB-ASI is how they move the compressed stuff, like MPEG streams, your cable TV channels, between big broadcast facilities.
And this unit handles the bandwidth for both.
Oh, yeah. It comfortably handles anything from, like, 0.5 millips up to 270 millips. The specs even say it can support these massive ASI streams up to 622 millips. It's a huge digital pipeline.
That is a powerful pipe. So let's talk about the physical side. It starts with that classic copper input, the BNC connector on a 75 ohming cable. What happens on the light side of things?
So once it's converted, the signal travels on a 9125 micron single-mode fiber. That fiber is really the secret weapon for getting that distance.
And the connection itself is flexible.
Very. It can use different ports, SC, ST, FC, whatever the setup needs. Broadcasters love that it's designed to be plug-and-play, and crucially, it allows for bidirectional transmission.
Which just simplifies the whole infrastructure. You can send and receive at the same time.
It makes everything so much easier, yeah.
But the real star of the show here is the distance. The sources list up to 120 kilometers. Is that a typical use case?
Not typical, but it's what's possible. Your standard out-of-the-box connection is probably good for 20 kilometers. That 120-kilometer figure, that just tells you the maximum potential of the technology.
So with the right lasers and high-quality fiber,
you can link signal centers in different cities seamlessly. The signal just won't degrade, even over continental distances.
And I noticed this F-1ASI is a single-channel unit, but the design is clearly meant to be scalable for huge networks.
Absolutely. The whole F-ASI series uses this smart multiplexing to boost efficiency. It means you can push 8 completely independent DVB, ASI, or SDI pipes.
8 different TV channels.
8 different high-quality channels, all shoved down one single thin fiber optic cable. Think of the savings in cost and infrastructure for broadcasters. It's massive.
So in the real world, this little converter supports pretty much every major media standard out there.
That's right. HDTV, video-on-demand streams, making sure everything's compatible with standards like SMPTE 310M for MPEG-2 video. This thing is the foundational bridge. It's the invisible backbone making sure you get high-quality media at the speed of light.
So to sum it up, the F-1ASI unit is this unsung workhorse. It translates heavy electrical video signals into light pulses, and that's what enables the high-quality long-distance transmission for the global infrastructure we all rely on.
Couldn't have said it better myself.
Before we wrap up, here's something to think about. The next time you're watching a live broadcast from halfway around the world, maybe a huge international event, just consider that the entire transmission probably relied on dozens, maybe hundreds of these tiny copper-to-optical conversions to make sure that zero-lag, crystal-clear signal made it all the way to your screen. It literally defines the speed of information in our world.